Hi, we are in section 2.7 Bayes Theorem. So let's look at one of the Bayes Theorem's examples. This is about printer failures. And I'm going to be very careful about labeling my events. That is usually the toughest part about doing a Bayes Theorem problem, is labeling your events. We have conditional probabilities, and in the end we're trying to find a conditional probability, so labeling is very, very important. So let's start off. We have printer failures. Okay, printer failures. Let's label that the event F. And printer failures are associated with three types of problems that a printer could have. A printer could have hardware problems. Let's label that as H. A printer could have software problems. Let's label that as S. And a printer could have there's other things that could cause problems. O. And I'm a little bit leery about using O when you're talking probabilities, so let's actually just call it C to be clear later, so we don't make a mistake and think we have a zero probability. These problems occur in a printer with the given probability values here, 0.1, 0.6, 0.3. So let's be very careful right now and just label that symbolically. So probability of a hardware problem is 0.1. Probability of a software problem is 0.6. And probability of a connector or some type of other problem is 0.3. And I feel like a picture is important here. These are three mutually exclusive events that are problems with a printer. You can't have, at least in this problem, we're saying you can't have a hardware and a software. It's exactly one of these three. So in a picture, the problems that a printer could have are broken up into these three mutually exclusive events. Here's hardware, just happens 10% of the time. Software, 60%, and over here, other is, which we're calling C, is 30%. So these are the problems associated with the printer, and you can see how nicely they're broken up. Okay, so the next thing, we're given some conditional probabilities, and I know they're conditional because I see this word given. That's a nice clue that you have a conditional probability. So what's the probability of a printer failure given you have a hardware problem? So what we're asking, or what we're actually being told here, is probability of failure given, so this little line here means given we have a hardware problem. So given we know hardware, probability of failure is 0.9. And likewise, we're given the following conditional probabilities in the next two clauses as well. So probability of a failure given we know we have a software problem is 0.2, and probability of some other type of problem, or sorry, a printer failure given some other type of problem is 0.5. Okay, so eventually what we're going to need to use, and I think I'm just going to go ahead and do this now. We've broken up into the failure, a printer failure, into the three types of problems. A printer failure, if you think about it, I mean, it can be sitting right on top of here. A failure can occur given it's a hardware. A failure could occur in here given it's a software problem. A failure could occur over here given it's a other problem. So using what we did in section 2.5, the total probability rule, let's just look at the probability of failure. Failure can only happen in these three ways. So we can have a failure given we had a hardware problem. So failure given hardware is in here, but times the probability we're even sitting in this the hardware little box right here, the little rectangle. So this is times the probability of hardware. The probability of a failure given a software problem, given that we're even having a software problem, plus the probability of failure given some other type of problem, times the probability you even have another type of problem. So we have to condition and then say what's, multiply by the probability that we're even sitting in the given region. And as you can see over here, I mean, it's most likely that we're going to be sitting in this software problem region. Given that we're sitting there, what's the probability we're going to have a failure? So what we're computing here is just the total probability of failure. Failure can happen in these three ways. And again, this is from section, if you want to go back and review, this is section 2.5, the total probability rules in that section. So we've actually gleaned all the information we can from the sentences given, but now we go to the problem statement. So a customer goes to the website, they're trying to diagnose, hey, I have a printer failure. what's the most likely cause of that? So given, I know now they have a printer failure, so probability, this is the given now, given they have a printer failure. What's the most likely cause of that problem? So right here, if they have a printer failure, what's the problem associated with that printer failure? Is it hardware or software or other? So what I really want to do now is find the probability of hardware given a failure, probability of software problem given a failure. So I'm trying to find out which is the most likely cause of the problem. So I want to look at those three conditional probabilities and find out which one of those is the highest. So I think what I'm going to do is just one of them, and you'll see the pattern. And if I can do, if you understand one, the others I would hope would make pretty good sense to you. So let's go ahead and find probability of a hardware problem given we had a printer failure. And notice, like in Bayes' theorem, you're really finding the reverse conditional of a conditional you've already been given. We're given the probability of failure given hardware problem, but we're now trying to find, given that we had a printer failure, what's the probability it's associated with a hardware problem. So I'm finding the reverse, if you want to look at it, I'm finding the reverse conditional. And this is when Bayes' theorem comes in handy. So let me go ahead and write out the total Bayes' theorem formula, and then we'll do a little bit of plugging and chugging, and I'll let you go ahead and reduce. So probability of hardware given printer failure is equal to, and here's where I'm using Bayes' theorem formula, so probability of failure given hardware problem times the probability you even had a hardware problem, all divided by what you conditioned on. And you conditioned on the probability of failure. So down here is probability of failure. So again, given that I have a failure, I'm sitting in the failure realm. What's the probability it's coming from hardware? So I think you could see in the basement is always going to be the total law of probability that you did from section 2.5. And on the top, you're just breaking it down into the different kinds of, if you had the hardware problem, what's the probability of failure? Otherwise, if you had the software, that would go here, or the other, that would go here. So the other probabilities I'm computing in the same way. And notice this is just the breakdown of the total ways of failure. So it's really just a ratio of this type of failure given hardware over the total probability of failure. So you can see this time the numerator is this first piece. When you do probability of software given failure, the numerator is going to be this piece, and likewise for other. So anyway, let's write out what we have. So probability of failure given hardware, that was up here, is 0.9, times the probability we were even sitting in the hardware rectangle, that is probability 0.1, and divided by the total probability of failure, which we did not write out up here. Well, if we did, this would have been 0.9 times 0.1. This would have been failure given software is 0.2 times 0.6, plus probability of failure given other problems. Let me see, that would have been 0.5 times 0.3, and that total probability of failure then would be in the basement. Then you can see I'm just taking the ratio of the first type of failure divided by the total probability of failure, and we'll get our answer. So I hope this makes sense. We'll do another problem, I'm sure, on Bayes' theorem, but for now, I hope that gets you started, and at least you can see how we're using Bayes' theorem, how the problem is developed, and I hope that you gather that the labeling is so important in this type of problem. Okay, we'll talk later.